Hi everyone and welcome back to Urban Informatics and Modeling. This is Josh. So for today we're going to cover Voxelizer. So Voxelizer is not a software and it's not a plugin for any kind of software, but it's actually a method in creating a form or a shape based on cubicles, little cubicles. So there are ways on doing Voxelizer from using 3ds Max, and the other one is using Autodesk Maya, and also you can do it through Rhino and Grasshopper, but for today we're going to cover from Rhino and Grasshopper. So the first thing that you want to do is just to download the plugin and go to Food for Rhino website and search for Voxelizer, just so. And the first item that pops out in the list, that's the plugin that you want to download. So before you download, make sure that you have the login account in here. I've already logged in, and if not, you are not able to download anything. So scroll on just a bit before downloading anything, because there are two download buttons. The first one's the top and the second one's this one. So the difference is at the bottom here, it shows the table of the versions of the plugin. So you make sure you want to have the latest version of the plugin, but sometimes you don't want the latest version because it doesn't work for some reason to the Grasshopper, but that's too specific. That's for a specific plugins like Kangaroo and some other plugins. I think Plankton also does that. So you want to download it, and here you go. It's already downloaded. Go to the Grasshopper component folder, which is in here, and just copy and paste the downloaded plugins to the component folder, just so. But before you restart, and you need to restart Grasshopper, but before you restart Grasshopper, you have to right click, open the properties, and check this unblock button, because if not, it's not going to be loaded to Grasshopper, and it's not going to be read as a plugin. So after that, just restart Rhino and Grasshopper. Okay, now we've already restarted the Grasshopper and Rhino. So if you go to the Mesh tab, and you'll see these two components, and that's it. The plugin has already successfully been installed. Now there are two components. The first one's Voxelizer, and the second one's the Octree Voxelizer. I'll show you what the difference is, but mostly you will use this one rather than the other one, because that's sort of like going from a bigger cube to smaller cubes, and it's sort of like a tree shape, like it branches. So that's the idea. Okay, so for the first thing that you want to do, I'll show you how it works. Is just to make a shape, extrude curve, make a shape, any kind of shape, and this is how it works. Just put the shape into the Grasshopper, hide it, and use this component. Now this component requires two input. The first one is a mesh, and the second one is the size. So the size will be in cubes. So for example, if you put in 2, it's going to be 2 by 2 by 2 cube, and 2 mil or 2 meters, that's going to depend on the size of this on the size of the unit that you use in Rhino. So for example, if you use in meter, then make sure that every number here represents meter unit. So the form that they want, that the component needs to be inputted, is the mesh. So we need to transform the prep to mesh using the mesh prep component, and then just translate it to preview off, and that's the result. So as you can see, it's using the shape of the prep as the boundary from where this is going to be built. So that's individual cubes that's going to be built, and you can see that there's a center point as well, and the result is that you have like boxes inside. As you can see, there are 616 boxes that build up this one single form. So what happens if you change the size of the box? And that's going to change the quantity of the box as well. So you can see I just made the box smaller and it increases by a lot. So the way Voxelizer works is that whatever the size you input for them, it's going to adjust, the quantity is going to adjust by itself based on the volume of this. So it's sort of like, so if in the mathematical way, you basically calculate the volume of the original shape, which is this one, and calculate the shape of each cube and divide it, and you have the quantity. For example, if you have 12 meter cube volume and you have 2 meter cube boxes, you can have like 6 boxes. So that's how Voxelizer works. But what if we want to have like weird shape and shape that is not conventional? Because box is really simple to make it, and what happens if we have like different shapes? So that I'll show you what's going to happen, but the principle is that it's still going to adjust to the original shape. So for example, if we make a sphere like that, and then we just change that, the boxes will adjust the quantity and it'll build up to create like a sphere, like just like that. So this is very useful for modular like buildings. And if you're in Melbourne, CBD, one of the example that we can have a look and use is that the Escape Tower in CBD by Denton Corker and Marshall that has a similar form. So it's sort of like a pixelated form, and it's very useful because in shapes that are weird, you want to have a rational form and rational grids, and Voxelizer allows that. So you can have like 3 different, especially in apartment buildings, you can have 3 different types of rooms that have the same rational, they have the same proportion ratio, and you can just repeat that throughout the building. So that's Voxelizer, and I'll just show you one more thing. If that is, for example, you make it 10, that's going to happen. It's going to I just made like more quantities to the boxes, and if I bake it just like so, it's currently loading, it's going to produce individual boxes rather than a really huge solid box. So that's quite convenient if you want to have it like that, but sometimes I just use a group. The reason why it's convenient because you can actually modify it. Copy, for example, you want to copy it, copy one item, and goes there, again goes there, for example, and you can just modify it manually rather than everything doing it right now. The next thing I want to show you is the octree. Octree has a different algorithm to it, and it's not really recommendable to sort of making buildings and making shapes from buildings, but it sometimes is also useful in creating like pathways, because you want to have pathways and Boolean method of form finding. But for making form like that, it's not really recommendable. So the way how it works is quite similar. So just do that. Just delete that one first. Right. So you can see that there's 2 different types of boxes actually. The first one is the smaller one, the second one is the bigger one, because how it works is that to have the bigger one first, and it's sort of like a tree branch where it's sort of going from the bigger one branches to the smaller one, and based on this group. So it's going to group like the multiplication of boxes. For example, you have four. For example, here you have like a 4 different small boxes, and it's going to create one single box. And if you have a group of 3 or 4, usually it works in 4 and 2 times fold, you're going to have like a bigger box. So these boxes have the same module with the smaller one, but it's a multiplication of 4. It's a cluster, and it's a combination of like 4 or 6 boxes at the same time. So that's Oct3, but it's not really recommendable if you want to make a building that's voxelized. It's better to use the previous one, which is this one. So that's that for today. That's Voxelizer. That's an introduction. It's really easy and it's really useful. Okay, so another thing about Voxelizer is that you need to make sure that your building is on the world coordinate, aligned to the world coordinate, because these boxes, these voxels, will be created accordingly to the world coordinate. So it's going to always make that orientation. I'll show you in a minute how. So for example, if you want to have a building that's on an angle that perhaps affected by your site, or it has to be oriented that way for some reason, for example like that, and this is from the previous exercise, you can just delete that and reselect the new, grab to this one that's on an angle. So the voxels created is going to align with the world coordinate. You can see here that the XY is at the right position, and the boxes are created according to that orientation. And it's always going to do that, and the only way to do it is to rotate it. So there are 2 ways. The first one is to rotate your building first beforehand, and then voxelize it and rotate it back again. And the second one is to rotate the box afterwards, but I'm not going to recommend that, because when you do rotate it after you voxelize it, you're going to lose certain amount of space, because there are some spaces in between like these that are not going to be used, and it's going to be not good at all. So what you want to do is to have this rotated first, aligned to the world coordinate, whether it's going to align to the X or to the Y. It really doesn't matter, as long as it's on the right angle with the world coordinate. But there's a way in doing it in Grasshopper rather than manually doing it in Rhino, because you need to calculate how much rotation that you need to do in order to achieve that Y or X axis. So the way to do it in Grasshopper is, for example, I want to do it in X. Oops, not that one. Unit X. And that's going to be pushed later on. Preview off. Let's hide this for a moment. You need to find the vector of one of these lines of the box, and align it to the X line, like that. I'll show you in a minute. So you also want to make sure that every vector is not sourced from outside of this box, to make it easier and to make the data consistent across the algorithm. So deconstruct the prep like so, and take one of the edge, this item. Make sure you have one either that way or that way. Don't take the vertical ones. And then that's lucky, because that's the first item in the list. And then points, you want to extract the vector of this line. So the way you do it is just to extract the endpoints and find the vector from 2 points. So vector to pt, which is here in the vector tab. So starting point to end point, and make sure it's the same across. The starting and the end point will be the same across. If not, there's going to have a lot of problem, because for example, you have the starting point here and the point of rotation there. The angle will not match up. So make sure that you have the starting point and the central point of rotation the same, or you have the end point and the center of the rotation the same. Basically, you want to have it consistent. After you find the vector from there to there, you want to match this vector, rotate this wrap from this vector to the x vector, to the x plane, like that. So what you want to have is to rotate direction. So rotate direction, it requires the geometry that you want to rotate, the center point of the rotation, the from initial direction, which is this one, which is that line there, to final direction, which is the x line here. So connect that to that, and connect that B wrap here. And because the center of rotation is not in the starting point or the end point yet, that's the result. And finally, you want to select the center of rotation like that, like so. And that's the result. You have successfully rotated this thing here into that, because that vector is the initial part here, and that x vector here is the result one. So we want to hide that. And starting from here, you can actually voxelize it. Make this one bigger, so just to make the grasshopper lighter. And you can have this voxels. And from here, you just need to rotate back. So it's the same principle as this one. You can just copy and paste it. So to copy and paste it, you just, when you hold this component, also hold Alt, and then just paste it here. So it's the same center point. You must have the same center point from there to there, and from there to there. If not, the center point is going to be different, and it's going to rotate in the other way. So what you want to do is just to reverse back the from and to. So previously we want to rotate from this vector to that vector. Right now we are currently in this vector, and we want to rotate it to the original position, which is this vector. So what we want to do is just to rotate, just to switch this off and change the geometry to this one. And as a result, you have voxelized the box on an angle, on an angle. So that's the same thing. So just to have a comparison and just to have a conclusion with this exercise, that's going to happen if you do not rotate it. That's going to happen if you do not rotate it. It's highlighted in the green one. And if you want to do that, if you want to have it aligned, you need to rotate it first. And that's the simplest process that you can that you can do. So what's the significance between these two? The significance is the amount of boxes in the end. So if you have a look with this component called list length, is going to count every item in the list, And since this voxels, they are individual box, there's going to be translated into one box, one item per box, And you see here, if you rotate it, you have 4,959 boxes. And if you do not rotate it, you actually have more. But the point is, there are difference in the numbers. Now that's going to depend on your site, and that's going to depend on the context that you are working on. Sometimes you do need to rotate it, sometimes you don't need to rotate it. But the thing with rotating it, with doing the voxels on an angle, is on the planning scheme is going to be very difficult. But in the end, it's going to be different for every context, and it's going to be different for every project. So it's really up to the decision that you made in the project. Okay, so that was the principle of using Voxelizer, and now in the application to our project. So in our project, which is in Dandenong, and this, you can see that there's a model of it. This has been covered in other video and tutorial for Elk and OpenStreetMap. And the way we do it in creating the voxelizer is that to find a mass that is affected by the sun. So we do the sun subtractor method, which is covered also in other video. And then that's define the massing of our building. So what do we do here is just to create a building footprint like that. So we did a courtyard in the front and to allow some sunlight and a 5-meter offset from the proposed site. What we did is just to extrude it, and then some subtractor, just like that, and it creates this kind of form. And we selected the bottom part just to create the mass of our building. So from here we already got a mass, and in the previous one we sort of looking at spheres and boxes. Now this is more of a complex shape, but Voxelizer also able to do that. And from here we also see that the same principles that I just discussed and I just explained to you about rotating the form just to get the voxelizer in the right orientation. So as you can see here, I did rotate the mass to be aligned in the y-axis, and we did a voxelizer and rotate it back, and we have the massing of the building. And afterwards, what we did is that we exported to be created in the plans, and the plans will be in according to this grid. So it's very simple, and it's very useful if you want to have a modular kind of building, a modular kind of orientation, a modular kind of layouts. And because these boxes are individual, you can treat it as a grid, and you can have rational layout, and it's fairly easy and it's very handy. So that's all for today. Thank you very much.